Welcome back to the makeup class on time series unit root test. So today will be the last class for this webinar. So now you import I want to import the data set. So this is the name of the data set. So let me just run this code to import the data set. Okay, so let me check if it has run. So yes, import data set imported. Okay, now let me go back to here. Now the next thing is to make sure you declare your data set as time series. So by running the line of code in 26, so let me run that. So I declare data set as times is very important you do that. Okay, it's because the variable I want to use the log of GDP, not at level. I want to use log of GDP. That's what I want to use. So I want to generate the log of GDP. So I generate the log series. So this is the command: generate, then L GDP equals log of GDP. So I'm running that. So let me also generate that of exchange rate, although I'm not going to use it in this class. Okay, these are the available tests in Stata on Fourier unit root test. Okay, we have Fourier LM test, we have Fourier ADF test, we have Fourier GLS test, we have Fourier KPSS test. Then we have Fourier FFFF test. Okay, so this one is a fractional test. Okay, fractional test. So we have Fourier double frequency test. So Fourier double frequency test. So we also have these are the 6 available tests. Okay, concerning Fourier test. Okay, concerning Fourier test. So the first four are competing. They are competing tests. Okay, so they are competing tests. They belong to the same group. Okay, while this, okay, so how do you run the test in Stata? So to run this test, you need to install a library called, so you have to install this library. So okay, just come here. So I've not done that. Let me just do it. So install, install. Okay, I've already installed that. Install the package. The package. So the name of the package you are going to install is Fourier UR. So how do we install the package Fourier UR? So you are going to type SSC, then install the name of the package. The name of the package. So let me just copy it here. Then you run this. If you run this package Fourier UR will be installed on your computer. Because I've already installed it, so I'm not going to run that. So you can do that. To read about this package, you can just come to your environment. And just come to the environment here and type help. Just type help, then Fourier. After installation, Fourier UR. Then if you press enter, so it will bring information about this package. Look at this, flexible Fourier form unit root and stationary test. So it is only one stationary test that is among all these 6 tests. So the stationary test is KPSS. Okay, and the non-hypothesis for all these tests, except this number 4, is that the series contains unit root. Okay, that is, the series contains unit root. Okay, rejecting the non-hypothesis for all the tests except KPSS test. Okay, that is 4, is that the rejecting non-hypothesis for all the tests except this test 4 implies that the series is stationary. Okay, but for this test 4, okay, if you reject the non-hypothesis, it means that that series is not stationary. So it's the exact opposite of the other test. That the non-hypothesis for this test 4 is the opposite of the non-hypothesis of the other 5 tests. Okay, and you can see how to run this. You can see description LM run Fourier LM. Okay, blah blah. Okay, so you can read. Take your time to read about these tests. Okay, you can see here you have unit rule non-hypothesis. So except this 4 that is non-hypothesis is stationary. No stationarity. So we have this fractional. So fractional unit root. So you can see it's still unit root. Okay, except this KPSS that is stationary. That has stationary at its non-hypothesis. You can see here it is written here that this Fourier KPSS has the reverse non-hypothesis. You can see. Okay, so you can take your time to read on this. So let me go back to the do file. So how do you run this test? After the installation of the package, I can run all these 6 tests at once if I run to one or. So I'm going to type the command Fourier or, implying that I want to run all these 6 available tests, and followed by the name of the variable I want to run the unit root test on. So the Fourier or, then L, that's log of rigidity. Okay, let me run this test. So all Fourier unit root tests completed. So let me start with the first one. Let me start with the first one here. So the first one here is Fourier LM test. Number Fourier LM test. So what I'm going to check here. This is LM is 4.009. Then when I compare these tests with the critical value at 5%, with the conversion or the conventional level, you can see this LM statistic is less negative, okay, than this. Therefore, according to this LM test, this series is not stationary. It contains a unit rule because you cannot reject a non-hypothesis. Okay, so let's move to the Fourier ADF test. Let's see. According to Fourier ADF test, you can see this ADF statistics is more negative, okay, marginally more negative than the critical value at 5%. So according to this one, we can reject the non-hypothesis of unit roots for this Fourier ADF unit root test. You can see, meaning that if you will see. So let's check the next test, that is Fourier GLS test. Let's see what happens. We are going to check the test. Can you see now? We have the test statistics. This is minus 3.95. When you compare with the critical value at 5, you can see that this is less negative than this critical value. So we are not going to reject the non-hypothesis. So according to this test, this series is not stationary. Okay, but if you check at 10% is stationary, that is not the conventional level anyway. So we are going to stick to our 5% conventional level. So this test statistics is less negative than the critical value at 5%. So for this, we cannot reject the non-hypothesis of unit root. Okay, let's check Fourier KPSS. Okay, this has the reverse non-hypothesis. Okay, let's check. You can see this KPSS statistics, okay, is greater than this critical value at 5%. Okay, we have 0.1516, then the critical value at 5% level is 0.0546. Okay, so the test statistic is greater than this, so we reject the non-hypothesis. So since the non-hypothesis here is that under this KPSS stationary test is that the series is stationary, but therefore rejecting this non-hypothesis means that this series is not stationary. So KPSS says Fourier KPSS stationary test results indicate that this series is not stationary. Okay, so those 4 tests are comparable, okay, directly. Okay, now let's see if we check these tests, this fractional test, okay, this fractional frequency flexible Fourier test. Okay, let's see. If you check this, let's see what happened. Okay, for fractional unit root test, okay, Fourier fractional unit root test, you can see that here, this is the test statistics. Okay, so the first thing you are meant to check here is to first check the F test. This F test will indicate whether the Fourier terms is significant or not. So once the Fourier term is not significant, so there is no point in using this Fourier in carrying out this Fourier unit root test. Anyway, so we can see this 22.229 is greater than 3.252. Therefore, Fourier terms, okay. Therefore, Fourier terms are significant. That's what it means. Fourier terms are significant. So that's what it means. Jointly significant. So we can proceed. Let's check the test. This is minus 5.749, and it is more negative than the critical value of 5%. Okay, therefore, according to this fractional frequency flexible Fourier test, this series log of GDP is stationary.